the second derivative test and the theorems, and then questions on homework. And problem number 5 is kind of hard. Algebraic is hard. Okay. We're going to do the second derivative test today. Okay. And we've done the first derivative test. Matter of fact, let's review that right now. No. No. Okay. Are you guys ready? This is a maximum, right? Now, what's true about the slope on the left? It's positive. What does that tell you about the function? It's increasing. Jack, put your phone with it. Then at the top, it's 0. And on the right side, it's negative. And the first, hey guys, the first derivative test says that if f prime goes from positive to negative, it's a max. What about this one, which is clearly a minimum, right? What's true about the first derivative on the left side? It's what? Negative. And on the right side, it's positive. I don't even care if this is 0 or undefined, but that's where I'd start to look. Okay, Declan? So if f prime goes from minus to positive, then we have a what? Minimum. Okay, that's the first derivative test. We did that last week. Actually, we did it 2 days last week. Okay, Brian, check. Okay, I want to look at this differently now. I want to look at this and use a second derivative test. Now, you will have it tested someplace on the exam. Probably a multiple choice question, where they will force you to use this other test. Okay, this is a maximum, right? What's true about the concavity? It's concave what? Down. So when my function at this c value is concave down, what would be true about the second derivative? It's negative. Okay, this is concave up. Because it's concave up, the second derivative at this point is greater than 0. So what you do to do the second derivative test, Stephen, is you find your critical points on the first derivative, find your second derivative, and evaluate your second derivative at those critical points. If the second derivative is negative, then I know the function's concave down, and then I know I have a max. If the second derivative is positive, then the function is going to be concave up like a cup, and it's going to be a minimum. Okay, that's what it is. My smartboard has a mistake here. Should say minimum, but I believe yours is correct. So you find the critical points of the first derivative. It's on the back of Fridays, sort of. Sort of. The test is there. We can do that example, or we can do the example I've got on here. What? Okay. Hey, guys. If the first derivative at my c value is 0, it even could be undefined for that matter, and if the second derivative is negative, this is what I do. I look at the second derivative. It's negative, which means it's concave down, so it's a local max. Yeah, it is. It's in the middle. The test itself is. Let me show you. It's right there. Second derivative test. Okay, if the first derivative is 0, okay, guys, and the second derivative is positive, then what do you know about your function? second derivative is positive, my function's concave up. So what do I have? A minimum. So I don't really memorize it because I already know what the concavity is. I'm just using concavity. And then I draw the picture and I figure it out every time because I can't keep everything straight. Jack, put your phone away. I'm sorry, what? These are local. These tests are only for local. To do a global, you need to have endpoints and a continuous function. Might have given them all away. I don't see any. Okay. Global, you either have to have a continuous function on a closed interval, Declan, or you have to look at the graph. We'll look at a problem today. Okay, I did the first derivative test. Let's do a problem. Now, this is a different problem than what's on your sheet. It's actually a better problem. I'm giving you the derivative of a function right there. And Sophie, please put that away. Okay, identify where the extreme values occur. How do you do that? Okay, Alexi, James, and Declan, you guys are chit-chatting too much because you weren't paying attention. No, you were playing on your phone. Hey, guys, how do I find extreme values? I look where the derivative is what? 0 or undefined. Is that ever undefined? No. So where is this 0? No, you don't. So take a piece of paper and write it down. Guys, shh. You need to be quiet. Casey. 4 and an x squared. It was given as a derivative. We're going to factor out 4x squared. I'm left with x minus 3. Okay, so where are your critical points? Okay, 0, 3. Now, I could do a first derivative test. Let's go ahead and do that. On a first derivative test, I draw a test line because honestly, I can't visualize that. Here's 0, here's 3. These are the zeros. And then, you know what, no matter what I put in for x here, that's going to be positive. Also, if you remember about it bouncing. So if I put in a -1, this is going to be negative. Then it's, but if I put +1 in here, it's still negative. If I put in +4, it's positive. So I actually know, Riley, what that looks like. My function is decreasing. It zeroes out. Then it decreases. Nope, it keeps going down. And then it flattens out and then increases again. We do at x equals what? 3. Not at 0. What do you have at 0? Nothing. That's correct. It does not, the derivative does not change signs at 0. Has to do that. Then depending on how it changes the sign will determine on whether it's a max or min. Okay, wait a minute. Guys, I cannot hear him. If you're going to do first derivative test, yes. It will not get you any points on the exam, but you probably come up with the right answer. Not 3. Let's find inflection points. No, a question? Might be. Looks like it is. Inflection points are where the concavity changes. That's up, and then it becomes down. If it's concave up like a cup, that's That's the definition. It's a definition. Will it hold water or won't it? This won't. That looks like a frown. Down like a frown. Okay, let's do the second derivative test. Okay, what's the second derivative of my function? Jack, I get 12x squared. If I do that, you get them too. And then what do I get? Minus 24x. Is that okay? Okay. Okay, so I can put in 0. I can do f double prime of 0. What do I get? 0. That didn't do me any good. It's possibly an inflection point. I just have to look to see if the signs change. What if I did f double prime of 3? That's equal to 12 times 9 minus 24 times 3. Is that positive or negative? It's positive. Do the arithmetic. What's this? 108 minus 72. So because the second derivative is positive, that tells me my function at 3 must be concave up. So it would be a local minimum. I did a first derivative test. I already had it. I'm just checking. The only time I do second derivative tests is if the second derivative is easy to find. In this case, it's easy because we do polynomials, but it's not always easy. You only test the critical points from the derivative. Now let's get concavity. Let's get inflection points. So 0 equals 12x squared minus 24x. We found one. Let's factor that out. What do you get? And then it's x minus what? 2. And again, I'm going to do a little sine graph, a line graph. Where are the critical points? Okay, now you test. You know what? I know that, hey guys, I know that that's a parabola, so I know what it looks like. It will look like this. So I always know that, which is nice. Because it's 12x squared minus 24x. That's a parabola. Good. I don't see a negative there. It's the x squared term. If the x squared term is positive, it's this way. Negative, it's down. When in doubt, test the regions. Try 10. That's clearly positive. Try 1. That's negative. That's positive. Try negative 10. Clearly negative. Positive. Sorry. Don't throw me off. Pardon? Edward, slide over, please. If I do him, I'm going to give you ours too. Okay, guys, ready? Jack? Just put in values. Put in 10 here. If you put in 10 right there, that's positive. That's positive. So if I put in negative 10, this will give me a negative number. That gives me a negative number, which gives me a positive. So, yep. Is that concave up or down? This one. It's concave up, concave down, concave up. What? Is 0 an inflection point? Stephen? Is 0 an inflection point? Noah? It is, because x equals 0 is an inflection point. No it's. because f double prime goes from positive to negative. On this function. Okay, guys, I can't even hear myself think. If the second derivative changes sign in any function, you get an inflection point. So do I have another inflection point there? At x equals what? 2. And this one, f double prime, goes from negative to positive. Has to simply change signs. Okay, guys. Can't hear. What? Yeah, it says where's the concave down, where's the concave up? Okay, we got the, where is it increasing? It's increasing from, where this is positive, 3 to infinity. Where is it decreasing? From negative infinity to 0, and then from 0 to 3. At 0, it's 0. To be increasing, the derivative must be positive. First derivative is what always tells you if it's increasing, decreasing. Second derivative gives you concavity. Questions? Where is it concave up? It's concave up when f double prime is positive, concave down when f double prime is negative. So it's concave up. Where is it positive? It's concave up from negative infinity to 0. These are always open circles, no thinking about it. And then from 2 to infinity. Concave down between 0 and 2. So I did draw this right. I said it was concave up. I drew it with concavity. At 0, it changes. It's an inflection point. Where does it change here? Not at 3, but at 2. Because you can see it's up here now. And I sketched my graph. I did it automatically. If the first derivative is 0, you're always going to be able to sketch it without a second derivative. That'll be smooth. Now, do you want to do the one that's on your handout? I know it's a different problem. So f of x, this is Fridays. And I don't have it anymore either because everybody took all mine. I don't know. I'm going to look at somebody's. I'll just borrow it. Okay. Did we do this? No. Oh, yeah, we did do it, didn't we? Well, let's do this with the second derivative test. Sometimes the second derivative test is the easiest way to do it. Okay, Brian, what's that derivative? Okay, how do I find critical points? Where the derivative is 0 or undefined. So factor out of 6x. So I'm left with 2x 1. Now let's skip the first derivative test because this is easy. Okay, Noah? Matt? Put your phones away, please. We can. Let's first do the second derivative test. Okay, ready? Lexi? What's f of 0? F double prime of 0. Okay, what does that tell you then, Jack? The second derivative, just put in 0. It means that this second derivative being negative means it's concave down. So this is a max. f double prime of 0 is less than 0. Concave down. We're going to do the other one in a second. Everything's up there. Okay. What's f double prime? Oh, where's the other 0? Yes, there is. 2x minus 1 is 0. No, 2x minus 1 is 0. X equals 1 half. So let's evaluate that at 1 half. So it's 24 times a half minus 6. So it's positive. That's right. So concave up. You would say because f double prime is greater than 0, therefore a minimum. Now, the request was to go ahead and do a first derivative test. And even before we do that, okay, guys, it's a cubic. What do cubics look like? If it's just x cubed, it looks like that. There's no max or min. But maybe, is there a global max and min on this? No. You have to know what the function looks like. Okay, so the question was, what's the first derivative test? What would that look like? Mhm. You are. But generally speaking, you'll prefer the first derivative test because it's easier to work with. You can use either one. It's what you want. But let's go ahead and just do a first derivative test. Critical points are at 0 and 1 half. And I'm going to work with this. Let's try and make sure I'm in the right place. So here's f prime. Here's 0. Here's 1 half. And I know that's a parabola. I honestly don't want to deal with putting values in there to see which way it's going to go. I know it's going to go like this. Positive, negative, positive. Because it's a parabola. 12x squared minus 6x is a parabola. You could test regions. You do have to deal with something between 0 and a half, which is not fun to do. Okay, so this first derivative goes from positive to negative, which means that my function is increasing, decreasing. It's a max at x equals 0. I'm not sure what you mean. Plug values in. Then you use the first derivative. Okay, guys? What's the other one? At 1 half. F prime goes from what? Negative to positive. So that means the function's decreasing and increasing, so it's a local minimum at x equals 1 half. There is no global. When do you guarantee a global max min? What are the two conditions? Continuous function on a closed interval. Girls. Pardon? Wait, what was your question? What's it? It might. This one doesn't. And another, okay, guys? Riley? Okay, guys? Here's another way you know. Right here. Are there any more critical points than what I have in my first derivative test? Jack, are there any other critical points on this? Besides 0 and 1 half? So guess what? My function is increasing, levels out, decreases, it increases. So I know it never turns around again. So I know there's no global max or min. There's no other opportunity to have another one. Yes. How about number 5? This is out of 4.3, number 5. It gets kind of ugly. So if you haven't done it, you should do it with me. 4.3, it's a homework question. It's disappointing because there really aren't that many good homework questions. And this one you get bogged down because of the algebra. It says use the first derivative test, which is hard actually in this case, to determine the local extreme values of the function. And identify any absolute extreme values. What's the domain of this function? Yes. Well, what's true about 8 minus x squared? Colin, what's true about this? Okay, guys? What's true about this? It's got to be what? Greater than or equal to. So x squared has to be less than or equal to 8. So x is going to be between 8, square root of 8, and negative square root of 8. Guess what I just did? Stephen, how's that going to help me? I just closed the interval. Domain. Okay, Jack, calm down. Let me show you what it looks like. That's what it looks like. Because of the domain restrictions, it looks like this. Now, we looked at that afterwards. There. I graphed this. There it is. I want to know what it looked like. Now, it looks like it doesn't go down. What is f of 0? Okay, I know this book said use the maximum existence theorem, but do I have a continuous function? And is it on a closed interval now? And it doesn't look like it because the tangents here are perpendicular. Okay, I'm just trying to smooth it out a little bit. Oh, sorry, less sorry. Okay, so since I have a continuous function on a closed interval, I'd rather use the maximum existence theorem. You will see why in one moment. Okay, so now we have to take the derivative of the monstrosity there. Because whatever's under that radical can't be negative. It's irrelevant. This one dictates the whole deal. It's called a natural domain. Okay, you guys, take the derivative. I'm recopying. And I'm going to make it this way. Hey, girls, have you taken the derivative? Sophie, how do I do this? Take the derivative. So how do you find y prime? It's the first times the derivative of the second. Oh, I forgot my 1/2. Now, what's the derivative of that? Product rule. So it's 1/2, 8 minus x squared to the what? Times, what kind of 2x? Negative 2x. It's the algebra. Okay, Jack, are you doing this with me? And then it's plus. I don't like that fractional exponent, so I'm going to make it back to this. Oh, it's my fault. It's crickets. Okay, times the derivative of x, which is 1. Okay, guess what you guys have to do with this? You have to set that equal to 0. Okay, it looks terrible. Let's make it look nicer. Okay, first off, what happens to 2's? So I get minus x squared. Is that okay? What's x times x? X squared. Now, I don't like a negative exponent. So that puts it in the denominator. And the square root, the 1/2 is the square root. Plus, I cancel the 1/2 with the 2. Oh, and that's just what it is. No, the 2's cancel out. So it's 1x squared. Okay, that looks better. You may not agree, but I think it looks better. So 0 equals negative x squared over the square root of 8 minus x squared plus the square root of 8 minus x squared. Okay? I'm going to move the negative x squared to the left side. And you know what? The product rule always gives me 2 terms. So since it always gives me 2 terms, I can always get a proportion. No, I can cross multiply. What do you get? I get 8 minus x squared equals x squared. So 8 equals, I cross multiplied, 2x squared. So x squared equals 4. What's x equal to? Okay. Where are the other critical points, you guys? Colin? Okay, you guys. Where is this derivative? Guys, please stop talking. Jack, where is this undefined? When that's 0. That's a critical point. So the 8 minus x squared cannot be 0. So x squared cannot be 8. X cannot be the positive square root of 8 or the negative square root of 8. But guess what? Those are the end points. So first derivative test on this is not very nice because my critical points are at my end points. Is that bigger or smaller than my 2? It's bigger. Pretty close to 3. How am I going to test this region in there and that region in there? Without a calculator. It's not going to be easy. So my preference on this problem, since I did get a closed interval, is let's just evaluate the function at these places. What is f of the square root of 8? Oh, you have to. You have to find your critical points. I just didn't do that because that was too hard. What? I didn't do the first derivative test. I don't need it. I have a closed interval and a continuous function. If I have a closed interval and I have a continuous function, what am I guaranteed? Maya. Right. And where might they occur? Endpoints? What is f of the square root of 8? If you put square root of 8 right in there, I get 0. What's f of minus square root of 8? I still get 0. You can look at the picture, you can see that. Because it's the square root of 8 times the square root of 8 minus the square root of 8 squared. That's 0. Is 8. The square root of 8 squared is 8. What are the other two values? You have to find f of 2 and f of negative 2. So what's f of 2? It's 2 times the square root of 8 minus 4. So it's 2 times 2, which is 4. Guess where that is? Right there. Okay, Riley? What's f of negative 2? It's negative 2 times the square root of 8 minus 4. So when x is negative 2, I get a minimum. It's right there. So it's negative 4. So this is why I would prefer the maximum existence theorem. It's just easier than the first derivative test. You want me to finish the first derivative test? We can. What's the easiest point to put into this first derivative here? 0. And I'm going to go back and look at this. What if I put in 0? That's 0. That's a positive number. Now, what if you put in 2.1? Well, this is positive. If I put in 2.1, this is positive, and that's negative. See, I got actually evaluate it. I don't know. I can't. Well, I just don't like it for that reason. But you would find that this is a negative, and this is a negative. No. Do we need to do a mean value theorem problem? I probably need to review it because it's on your quiz tomorrow. Pretty close to square roots are always positive. Okay, should we look at review the mean value theorem? Okay, the mean, huh? Well, that was section 4.2. That's why you need to do the homework. Mean value theorem, there's 5 theorems. We have done 3. I have gone over this one today. You used that one on the last example. And the mean value theorem is the other one. And the mean value theorem says I must have a continuous function. Okay, you guys are going to miss this on the quiz tomorrow, those who are chit-chatting. Plus, I like it quiet. On a closed interval. Now, what has to be true about the interior? The function must be what? I already got continuous. Differentiable. I don't care about at the endpoints. So on the mean value theorem, it did apply in that last case, even though the endpoints, the derivative did not exist at the endpoints. I don't care about that. Just the interior. Then you draw a picture here. This is the secant line. Okay? And it says the slope of the secant has to equal the slope. There's got to be someplace on here that if I draw a tangent line, these will be parallel. The slope of the tangent line. Okay, that's just it in words. What is the slope of the secant line? It's just slope. Yeah. Yeah, it's f of b minus f of a. I didn't label them on here, but you guys know what I mean. All over b minus a. What is the slope of the tangent? F prime of some value. We don't know where it is. We'll call it c. C is between a and b. That's all it is. The average rate of change somewhere has to equal the instantaneous. So you have to know the 2 theorems in these first 2 sections. That's the mean value theorem. We can do a problem out of your homework if you'd like. First, I always see whether or not it applies. If it doesn't apply, I forgot to put up my opener. but I can bring it up if you want to look at it real quick. How do I check what? You take the derivative. Here it is. Ooh. This is 2011, number 4. This last year's. Okay, this is question 4. I only gave you part of it. It says I have a continuous function, and it's on a closed interval. And we have these shapes here, which I would think when you're looking at those shapes, kind of begs you to find the area under the curves geometrically, because you could do it. And that's exactly what we're going to do, but we haven't gotten that far yet. But part D says the average rate of change on the interval. It says find the average rate of change on the interval. What is the average rate of change? What's this ordered pair here? 3, whoops, I always do it backwards. What? Oh, wait, what interval do I want? Oh, from -4 to 3. I want from here to here. That's probably why they gave you the numbers. So I just want slope. So it's what? -3 minus a -1 over +3 minus a -4. So what am I going to get? -2, 7. Okay, was that hard to do? No, that was worth a point. That was all. This is 2. Then it says the f prime of c is equal to, it says there is no point. You have to read these carefully. There is no point where f prime of c is equal to the average rate of change. Explain why the statement does not contradict the mean value theorem. Why does the mean value theorem not apply? That's what it's asking for. I have a continuous function on a closed interval. What's the problem? It's not differentiable. Where? It's 0. And actually, it's because of that you cannot find a tangent line. You can try and draw one up here, but you'll never find one that's parallel to that. And it's because it's not differentiable there. So it's an easy problem if you know the theorem. Now we can do another problem out of homework, which would be section 4.2, I think. Yes, it does. We always have fun. Let's see. Anyone in particular that bothered you? Did we do 9? Any of these that you want to look at on 4.2? I don't know if you have questions on. Okay, 25. Is that a mean value theorem? Okay, we're going to look at 4.2. Some of these problems are hard. This is one of those. This is not the mean value theorem. Any of these. Yeah. It just asks you to find the local extreme values. I want to know where my function is increasing and where my function is decreasing. So that tells me I have to do the what? First. Second derivative gives you concavity. First gives you increasing, decreasing. So it's the denominator times the derivative of the numerator. Whoops, minus 1. Minus a negative x times the derivative of the denominator. Okay, so that's equal to minus x squared minus 4 plus 2x squared. Correct? No. Well, this wasn't that hard, was it? What 2x? 2x times x is 2. Then I added negative 1x squared plus 2x squared. Okay, is this ever undefined? Think about that. This is a parabola. This is a parabola. It's never 0 because its parabola shifted up 4. Doesn't matter. It's not 0. Give me an x where it is 0. So the only thing I have to worry about is where the numerator is 0. So x squared minus 4 equals 0. And I like to do x minus 2. I prefer to factor. So the critical points are at 2 and negative 2. And then I know that's a parabola opening up. So this is positive, negative, positive. Okay, so it's increasing from negative infinity to negative 2 and from 2 to infinity. And it's decreasing in between them. Now, if you want to test regions, that's fine. Just make sure you get it right. I just recognize it as a parabola. A lot easier. And then did they ask for max mins? I think they did. Now, is this ever going to turn around again? No. Okay, so I'll probably, I don't know what I'm going to have. I just know it never turns around. So what happens at negative 2? My function's increasing and decreasing. So I have a max. And now this is negative positive, so I have a min. It's not a closed interval, so there's no guarantee. There are no endpoints. And it just asks for local extreme values, so there they are. And why is this a max? Because f prime goes positive to negative. F prime goes negative to positive. You need to practice with this because when you get to the exam, you're not going to remember the stuff you need to put down. You're not going to remember the reasons. You might get it right. Did I do it wrong? I can't hear you. Time to go. Oh, let's stop this.